Please do. So this is a relative maximum right there at 0. And then we'll try to sketch the graph of f prime. And this graph sketching is stuff that we did a lot of in like August, September. So I'm hoping you're okay with something like this. Does that look okay? Looking at some pretty good looking graphs here. All right, so what observations can you make? What connections can you make about the patterns of what's going on with f and what's going on with f prime? What do you see? This is where, again, please just feel free. It might sound silly in your head. It might be the most brilliant thing ever. Let's just get it out there. What do you think? Say it one more time.
F of x is a concave down.
Yeah, f is concave down. That is a little bit of an unexpected observation, but actually very insightful, and we'll use that a lot Monday or Tuesday. That's a really good observation. We'll come back around to that for sure. What else do you see? Yes, sir.
On the graph of f prime, there's a 0 where the max is unattacked.
So the relative max of f goes with f prime equaling 0. What do you think about that? Do you see how the 0 on f prime is in exactly the same spot as the relative max on f? Okay, so let's see if we could draw a conclusion here, because this is exactly what I asked you to do. Connect the behavior of f with the behavior of f prime, right? So would you guys say that this would be okay? Don't write this down yet. Let's make sure it's right before we write it down. I'll say if f prime equals 0, f has a relative maximum. You think that's true or false? Or false? What could I do to change this or add to it or something?
Add also, it could be a minimum.
Okay, if f prime equals 0, f could have a max or min, or, this might be controversial, neither. So when f prime equals 0, that could very well be where you have a relative max, min, or none of the above. So since this was a relative maximum, let's see if we can add to this a little bit and get to a place where we can say this is where we have a maximum. So I'll start you off here. I'm going to say if, and since we were talking about, I'll put it like this. I'll say since f prime of 0 equals 0, right? We all said there was a relative max there at 0, and that went along with that 0 on f prime. Since f prime of 0 equals 0, and f prime does what? What leads us to a relative maximum? Ooh, there we go. If f prime and f prime changes from positive to negative. Since those things are true, f has a relative max at x equals 0. Nice work. A number of you contributed on that one. That's pretty good. Put in some good things there. And later on, we're going to find out that Carter's idea of, hey, f was concave down the whole time, that actually goes nicely with a relative max as well. We'd just be approaching it from a slightly different perspective, but it goes together really nicely. Okay, so we'll formalize this here in a few minutes. How is this sitting with you right now? And by that I mean, does this seem logical? Does anybody feel like, no, it does not? I hope you do. Let me put it like this. Let me add one thing into this, just in case maybe somebody's just hanging on. Finish my sentence. If f prime is positive, f is increasing. Thank you, Cole. And if f prime is negative, f is? So wouldn't it make sense that if f went from increasing to decreasing, wouldn't there be a relatively high point somewhere in there? And when we say that f prime went from a positive to a negative, aren't we essentially saying that f went from increasing to decreasing? Okay. So let's take a look then at our other couple here on this next page. These might go a little bit quicker. We'll see. So we'll talk about the top one first. So on that top one, would you guys say relative max, min, or neither? What's being illustrated? Min. Yep, we got a minimum. And where is that minimum located? Right there, yeah, right there at x equals negative 2. Take a second and sketch the graph of g prime. Man, that's a nice straight line. I can never do that unless I cheat and use the line tool. It's pretty good work. Nice work. Today in BC, I drew a perfect parabola.
Really?
Which is so rare. It's like they always have like this lopsided part. It's like I drew it.
Good, and the other side looks
Right.
really
You get one half right and the other half's ugly. In fact, the kids in BC were there like, whoa. And I was like, we should save this because I never do that. Okay. So you guys okay with that pattern for G prime? That graph for G prime? Okay. So here's where we want to make some more observations. Perhaps similar to the ones we just made. Different, but similar. What would you say about the behavior of G prime and the fact that we've got a relative minimum at x equals negative 2? What would make sense to you? So what is doing this? You said, because you said it is doing something.
G of x is going from negative slope to positive slope at x equals negative 2.
Well said. Okay, so are you guys okay with this part here that we say G prime of negative 2 is 0? That's where all this is going to happen. It's the most important point here. Later on, we're going to call it a critical point. Right? This is a critical point here. And what Carter said was G goes from a negative slope to a positive slope. That's what's happening, correct? We're going to want to put this in terms of G prime. Like what he said is not false at all. It's completely true and logical and valid and good. However, we want to word this a little bit differently. We want to word this from the perspective of G prime. So if G is going from a negative slope to a positive slope, what's G prime doing?
Going from negative to positive.
Going from negative to positive. So it's pretty well spelled out. I think both are well said. I would favor this one for sure. So we'd say G prime of negative 2 equals 0, and G prime goes from negative to positive. This means that G has a relative, I usually just put REL for relative, minimum. These are relatively high points and relatively low points. It's not the absolute extrema like what we've been talking about. This is just like a small little hill. It's not the highest in the world. It's just a relatively high point or a relatively low point. Okay, and then the last one here. Would you guys say that this graph of H demonstrates a relative min, max, or neither? Neither. Okay, I agree. If you haven't already, take a look and sketch what you think H prime would look like. We can think about the behavior of H prime connected with graph of H. So I notice here that Cole has kind of a parabola looking graph. Do you guys agree with that on this H prime? Oops. You guys agree with that? H prime is positive the whole time except for maybe right there at 1. Right there at x equals 1. Okay. Okay, so this is where there can be some confusion here, because would you guys agree with me that h prime of 1 equals 0? But you can clearly see that h does not have a relative min or max. Why would that be, Reese?
Because h prime doesn't change signs at all.
Right? H prime is positive and remains positive to the right of that critical point. So h prime of 1 equals 0, but h prime doesn't change signs. Therefore, no min or max is there. It's neither. So earlier I said, hey, if h prime equals 0, does that guarantee that you'll have a min or a max or whatever? And you all said, no, it could be a min or a max. It could be the other one. The truth is it could be neither, right? Yes, ma'am.
Okay. What you just said confused me.
Okay.
Because it,
You just started your sentence with it. Think of a different way to start it.
never mind.
Are you still confused?
I don't think so.
Was it the change signs part?
Yeah, because I was looking at H and that, yeah.
Now, h changes signs,
Yeah.
no question. But h prime goes from positive to 0 to positive. So it never actually changed signs because 0 didn't have a sign. We good? Let me formalize this for you. This is going to sound really familiar, mainly because you guys have done some really awesome work for the last few minutes. So everything we've been talking about is leading us towards something called the first derivative test. That's what goes in the blanks. First derivative test, there we go. And this is not a creatively named thing, because quite literally, this first derivative test tests the first derivative. Like, that's what it does. That would be, instead of calling him Zach, saying the guy with the blue coat doing math, right? I mean, that's what this is named for. It's named for what it does. So a formal presentation of this first derivative test follows. And if there's a first derivative test, I'm sure you can well imagine that there is also a second derivative test. That's what Carter was getting at earlier. Even if he didn't know it, that's what he was doing. Okay, so here we go. First derivative test starts out with this. C has to be a critical number, and the function we're dealing with needs to be continuous, differentiable, except possibly at the critical number, because a sharp point could be a relatively high or low point. So the first derivative test comes in 3 parts, kind of like those 3 parts we just did. So here it is. If f prime of c equals 0, and f prime changes from a positive to a negative at c, then f has a relative, let me retry that. Yeah, relative max is correct. Relative maximum. Number 2, second part of this, if f prime of c equals 0, so in other words, c is a critical point, and f prime changes the other way, this time from negative to positive, then f has a relative minimum. And finally, if f prime of c equals 0, but f prime does not change signs, then f has a neither. Yes, we'll just say neither. Neither a min nor a max. Okay. How are we doing? We're going to do one example. We've got about 8 minutes. Okay, here we go. Let's give you a little tutorial on how this works. Hey, can I ask you just kind of a rewind question? This would be a good comparison here. What are the candidates for absolute mins and maxes? Candidates for absolute mins and maxes. Yes, Luke.
Endpoints,
Endpoints?
where f prime
Just call them critical points, but you're describing them well, where f prime is, or
non-exist.
DNA, and we're gonna call those just critical points.
Okay, so we don't have the same every time.
You don't have to expand it every time. No. So guys, listen up. Listen up now. When you first read this question, it says, find the critical numbers of f, blah blah blah. Apply the first derivative test. Identify all relative extrema. Oh, finding maxes and mins, right? Well, aren't the candidates for maximums and minimums endpoints and critical numbers? Tell me where the endpoints are. There aren't any, are there? This is simply a relative max or min we're looking for. We're not asking what's the absolute highest point on this graph. We're basically just saying, where does this graph go from uphill to downhill or downhill to uphill? We're looking for a relatively high point or a relatively low point. So the candidates for relative extrema are just critical points because there are no endpoints. Okay, so here we go. Step 1 says find the critical numbers of f. And Luke, in honor of you being so thorough, could you tell us what critical numbers are?
Endpoints, but not here.
No. Critical points, if I say what's a critical point and you say endpoints, I'm going to stop you right there. Endpoints are candidates for absolute extrema, but critical points, that's what you said earlier.
F prime is 0 or does not exist.
So if we're looking for that, shouldn't we find f prime first? So, a couple of power rules, bless you. F prime equals 3x squared minus 12x. Let's take an educated look at this. Is there any place where f prime won't exist? It's just a parabola, right? So this will always exist. You were thinking set it equal to 0, right? That's it. There's no denominator, so I think we're good on that. So if I set this equal to 0, what would be my next step in solving this? Factoring, yes. In fact, you could factor out a 3x, couldn't you? So 3x times x minus 4 equals 0. That means my critical points would be x equals 0 and x equals 4. Those are my critical points. So I've mission accomplished on the first task, right? Find the critical points. Then it says apply the first derivative test. And I want to say this again because I feel like I said it before and you were just like, yeah, whatever. This is called the first derivative. I hope you're listening. This is called the first derivative test because we test the first derivative. We test it out and see what it does. So can anybody think of maybe a visual aid that would help us in testing out the first derivative? What do you think?
I was like, sign, like a line where the sign switches.
The sign chart.
Sign chart.
Yeah, this would be an excellent use of a sign chart. So I'm going to do this. I'll do this off to the side. I will put my 0 here and my 4 right there. I will label this with an f prime because I'm not testing out f. I'm not testing out f double prime. I'm testing out f prime and seeing what it does. So what would be a good test value for this pink interval? Did you say 1 or negative 1? I don't think 1 is in the pink interval. Negative 1's in the pink interval. Now here's the thing. Hey guys, this is where if you lose focus for a second, you're going to get really, really lost. When I test out the pink interval with negative 1, should I plug the negative 1 into f? Or should I plug it into f prime or something else entirely? Why? Because I'm testing the first derivative. That's right. I'm not testing something else. I'm testing the first derivative to see what it's doing. So f prime of negative 1 would equal 15? Yes, 15. How about this red interval, a 1? There we go, Cole. That makes sense. So f prime of 1 is negative 9. And then how about over here on this yellow interval? 5 makes sense.
15.
So f prime of 5 would be 75 minus 60, which is 15. And I've got these lovely signs in my sign chart. This is where I can finish. And it does say justify your answer. I want to give you a nice example, or what I feel like is a nice example of how you could do this. So I'm going to say f prime of 0 equals 0, and f prime changes from positive to negative at x equals 0. Therefore, what do I have on the graph of f? Relative max. Yeah, there we can say, therefore, f has a relative max at x equals 0. Now, I write these justifications and conclusions all the time, and I find myself, there's a variety of ways I write them, but they have all these elements in place. I'm mentioning that 0, x equals 0, is a critical number. And I'm mentioning that f prime has a certain sign change pattern. Okay, and then the other one would be f prime of 4 equals 0. And f prime is doing what? Changing from? Negative to positive. Negative to positive. Therefore, f has a relative what? Minimum. There we go. At x equals 4. So those examples there of those conclusions and justifications, you need to be able to write something like that. It's one sentence, right? I don't want you to write a paragraph. I want you to write one really good sentence explaining yourself, and we're good. You guys are out 11 seconds early. Enjoy. Have a great day. After all the times I've kept you late, enjoy your... Well, now it's gone, so never mind.
Now we're on time. After calculus, after almost had it.